well then you better have a very, very adaptable architecture, because you constantly want to think, okay, what if we tweak this a little bit? What if we remove this component with something else? What if we remove a certain search engine with Lucene or another very high performance search engine? So it's these kinds of questions you need to take into account. Strong process, well we talked about this. So a strong process can overcome negatives of offshore development. So this is very important. All these things are almost twice as important, I would say, if you're thinking about an offshore situation, where you have a team in India or where you have only developers in India. So every 1% increase in outsourcing of tasks decreases productivity by 0.7% and quality by 1.5%, so more defects. I recently had quite a painful example of this. It's the project I was talking about earlier. And I might show you some things where translations went wrong, where a Romanian guy did not completely understand the Dutch regulations and similar problems. But we'll get to that later. Alright, so here are some points. So in most cases, avoid waterfall. Well, I think that was clear from 2000 onwards, so you will not find a developer that says, no, we need to do waterfall. So let's go easy. Divide long projects into subcycles or milestones of a few weeks or months duration. One thing that's really important also about this is that if a development team finishes a certain milestone, that gives a great deal of satisfaction, especially if it's on time. Because then the development team is like, wow, we're on track. Let's celebrate. Let's, at the end of the week, have drinks or something. Because we're obviously doing something right. So that's why this is a very good thing. Evolve requirements incrementally. Do spec refinement, coding, and testing concurrently. Well, this is a really important point. At Platen, they do it in a very cool way. First you get to this level of, okay, so we have requirement number 1, no estimation yet. We don't know if it's going to be 4 hours or 2 hours. The first business guy writes, okay, we would like the product to do X, and we envision it that it's going to be this way. So it's going to be about this much. Then the developer looks at it and says, I think I would do it like this and this and that. I think this is the design that comes with it. And maybe he or she turns it into a document of maybe 5, 6, 7 pages, saying, okay, this is how I would do it. Then the business manager takes another look at it and goes, oh, well, if that's possible, I'd like to add this, maybe change this a little bit, and start making changes to it. So in the end, we have a document of about 20 to 25 pages, in which they also have to describe an acceptance test. So how will the tester say, this is finished, or say, well, this is not finished yet? So that's, and then you have a document of about 25 to 30 pages describing the whole requirement. Now, that might seem like a lot of work, but for a larger product with a very long lifetime and very many different stakeholders, it's the only way to do it. And we propose a few rigid rules to force frequent synchronizations and periodic stabilizations. So, we had this discussion a little bit about the Rockstar developer. What if a Rockstar developer just runs away with this component and writes beautiful code that doesn't work with anything else? Well, then you have a real problem. So with these kinds of rules, you can say, hey, it's fine. Go build whatever you think is important and go work on whatever you think is important. But make sure it works in the larger context and that it delivers, that it does what it's supposed to do. So synchronize and stabilize. Well, synchronize and stabilize is sort of a typical thing to say. Okay, you want to get to sort of a stable build before you start. Let's say you have a version with 10 bugs and you're developing every weekly iterations at the beginning of a project. And you say those 10 bugs, we'll leave them for later. Then the week after you have 20 bugs, plus those 10 bugs. Then the week after. And the problem is these bugs are not standalone. You know, if you have one bug that needs to be fixed, maybe it's dependent on another bug. Maybe a developer sees that bug, knows that it can't be fixed right now, so then he or she starts anticipating that that bug will work. And then later, well, you can imagine once the bug is fixed, that developer's work will be broken again. So, you know, the synchronize and stabilize simply means make sure that you stay at a sort of a regular number of bugs. It doesn't matter if it's 10 bugs or 100 bugs, as long as it's sort of stabilized and you don't introduce more and more new bugs. So here you see some very interesting, so here you see, well, phases. It's not 7, it's more this time. So testing, daily builds, debugging. And here I think we see an example from Microsoft Netscape. Microsoft used to do it like this. Now they've become even more agile. And here you see different milestones, and here you see going towards actual release. So here you see alpha release, beta release, final release. And here you can really see, okay, there's a code complete moment, there's a final test, final debug, stabilize, and a final release. So these are the phases that Microsoft products have gone through. Yeah, that's all I want to say about this. Well, I think most of the things here I already mentioned and are really important. Yeah, building quality continuously. This is something that I've learned the hard way, I'd like to say. I've delivered products with my company that were of okay quality, but had we constantly first fixed the bugs and then worked on the new features. But of course you want development to speed up. You're always like, okay, what can we show the customer next week? And by that you then let fall or you drop some of the quality requirements, and that's really dangerous. So gates and checkpoints really important. Yeah, I'll show some nice examples of that later. Continuously test, fix, and integrate. Well, we talked about that as well. And automate. I think that's one of the most important things. So we talked about these integration builds. So let's say again that Joey finishes his component, I finish my component, but we haven't tested them together. Now, if you force us that whenever we commit our code, that we first have to test them together, you always have a working version, and always having a working version should go above anything else. So that's why that's really important. If you can automate this, that whenever I commit my code, I immediately receive an email saying, sorry, your commit has been refused because it doesn't work in its larger context. And then you first have to make sure that it works, which is a great way of forcing developers, okay, deliver quality. Yeah, test and retest, so automated testing. One tool that I don't know the name of right now. Does anybody know the Firefox plugin? That's also a web development testing tool?
Firebug?
No, not Firebug, but that's a good one. And Firebug is good for feedback. Now I'm talking where you can say, okay, first click in this screen, then click in that screen, and do that every time. Well, I'll come up with it later, I think it's with it. So Selenium. So what Selenium does, in Selenium you can say, okay, now go to this screen, enter this and this and this in these fields, and you can sort of create these automatic test scripts on a website that they make sure that every time you go through that, you change something about that website, that those tests still run. And if they don't, well, something is wrong. Either your test was wrong, or you've created bugs. And usually it's that part. Usually you have to change the complete site in such a way that it changes everything. So those are the kinds of things that also you should, if you develop a product, do more. Well, you always still need people. Yeah, and also writing automated tests will take you time as well. So the trade-off, there's still, well, a lot of discussion on whether it's really efficient to write tests or just write good code. I think that testing is essential, but especially in an outsourcing environment. And you also need human testers to probe real behavior. Because I've seen, well, I know this one girl, she's a bit of an autistic girl, and whenever I put her behind one of my products, one of my websites, she breaks it within minutes. It's very annoying. She always knows these SQL injection attacks and simple things like that, and just things you forgot, and she will always sort of punch through it right away. So whenever she finds a bug in over 10 minutes, I know my product's good. It's ready to go to market. Over 10 minutes is good. Well, some concluding comments. I think it's already clear that there's no one best software development method. In part, you want to use self-organizing teams. In part, your product might be dependent on hardware, sort of restricting you in the way you can build things. In part, your company might be a bank or a military organization where you have to be very secure, work from face to face, do lots of discussions. So I think the NASA people, for instance, they say we are a no-bug organization. I think the Curiosity rover, I think up to now they found only like 3 bugs in 10 million lines of code or something. So I mean that really does say that they have the best minds working on these projects. So it depends on, like it says here, match process with project business context. Yeah, I think this all makes sense. So team experience, how experienced is your team? If it's a bunch of 22-year-old Indian developers, be very much on the process and quality. If you have a team of 5 40-year-old rock stars, then just let them build because they'll do fine. Well, here you have another overview. Oh, it's quite cool. This is a slide from Michael Shimano. So what's the difference? Well, for custom software, you have schedules, requirements, price, technologies. set through negotiation with the customer, whereas for products, negotiation with product managers or executives, based on competition, partners, channels, etc. So prototypes, iterative design, useful to define features and get potential user feedback during the project. Waterfall may work fine if requirements are well understood or features can be frozen early. So 2 years ahead of time we say, okay, 2 years we want to have this product, and now we can see whatever the hell happens. So you can see that this is a bit Microsoft influence. I would say that most companies are working along with Scrum now anyway. So custom, well, many different process possibilities. Let me see. Yeah, so ahead of time you already need to sort of estimate, and estimations are always off, especially in software development. So, well, customers often want a waterfall process for the contract. They'll say, yeah, just finish within 5 years and then we'll see how it goes. Whereas what you want is regular increments. And also you'll see that, imagine here, that the customer will say, actually, we're happy with this. So we're finished now, which can be terrible for the contractor, because the contractor was expecting 17 extra phases. So, well, these things, you can imagine it's pretty tough to work in an incremental way in a custom project, although it has certainly its advantages. Was there a question? Or? No? Right. Well, special challenges for startups. Well, here you see the 4 steps for startups: customer discovery, validation, customer creation, and company building. So you can imagine, this is sort of how you start your company. And, well, there's a number of things you need to take into account. Especially startups, of course, need to start iteratively, maybe deliver every week to your customer, or show your customers every week what your new changes are. And just being a skilled product developer doesn't make a successful product, obviously. But like I said before, if you don't know how to engage the market, if you don't know how to get market requirements, you can't build the right product. So you can't build the solution that people are looking for. Yeah. Alright, so now I can show you, okay, let's first do the boring part, do some admin. So the rest of today, about 15 minutes, I'll be talking about Aaron Carmel. Aaron Carmel is sort of this important guy in the product software literature. He's one of the first guys to start saying, hey, products are different beasts than projects. So let's take a look at them specifically. So he did a study, he did different studies, but here he presents a study from 12 starting product companies. And he started to look at successful approaches and software delivery lead time. So how long does it take to develop a product? So in tailor-made software world, software is always late. So how does the product world deal with this problem? That software is always late and the planning always goes too far. So here you see some work from Carmel. Package software teams, what makes them so special. Time to completion factors in package software development. Well, we'll get into the details in a minute. Here are some nice papers. Okay, now let's see if we can. Uh-oh. You might have to start with an Explorer. I would like to open. Didn't expect that. Click to play. Oh, maybe. See if we have sound. We do not have sound. Sorry for that.
Six months? At least. 1 month to build the product and 5 months to play games on my computer. 1 year, unless you add people to my tiny empire. 18 months! Two months, and it solves every problem you have.
Give me the beta test version in 1 month. Cardboard? That's stupid.
Oh, then it's beta.
So as you can see Dilbert too was a little bit good about software development, and well, you saw the padding of the schedule and all the different. In companies there's lots of politics about around software development, and what I'm trying to teach you is to avoid all the politics and just get a nice product out of the door. So, well, what you see here is sort of a general process model for software development. This is partly based on the work by Carmel, but also partly based on Jacques' experience at Baan, and partly based on my own experiences. So what you see here is at the very top you have an idea, then you have a requirements loop, you freeze the specifications, a quality loop, and a general release. And so this is more the waterfall type way of thinking about it. And this is especially in a product company where maybe you release a new product every month or every year, or where this is still, it's fairly traditional, but it works, so to say. Yeah, important of course is designing code until quality threshold is reached. So one thing that you could say, okay, we do not want to deliver the product with any bugs that we know of. So that's probably an impossible way, and at some point you have to cut yourself short and say, okay, maybe 5 bugs is permissible. But you can imagine saying, okay, we want at least this level of quality before we release it to customers. So here you have a nice example of the requirements loop. Of course, not all these are in there, but well, you start with your preliminary requirements, doing some initial screening. So this is where, of course, you start thinking like, yeah, it's nice to have a print function here. Do we really need it? Or it's nice to have this reporting feature, but do we really need a reporting feature, or do you just need one number that the manager is looking for from this particular product? So then you have your initial requirements and technical specs, you build a prototype and refine, you continue, you have an internal review, an external review, concept go or no go, satisfaction decision point, free specifications, frozen specifications. So here you see a nice UML model of a design process. Now, typically, I would say this is a very traditional way of looking at it. This is not looking at it from a point of view where requirements evolve continuously, and you also have a team of product managers working in the background to specify requirements. But that's something I'll save for later. And this is still a great way to develop software. Let's not forget, Baan was a very successful company while it was, and other companies this is based on are still successful. Well, then you have the quality loop, and the quality loop, we didn't talk about this so much, but I wanted to mention it definitely. Well, then you got design, coding, complete product, QA point, then you get an alpha test product, again QA point, defect removal, beta test, well, and maybe you have to go back to B again, defect removal, final testing, manufacturing, and putting it out there. So can you tell me why you go to this final, why is there a manufacturing stage? What do we talk about that? Why can't we just put it on the web and have people download it? What does manufacturing mean? Okay, let's say exact developers are done. So their team of